Now our next speaker, he knows exactly what ICPMS is. He's an acclaimed gemologist. He's a very young man, a very big guy, so you can speak as long as you wish. I will not complain. And he's a field gemologist. Then he will discuss the term, but he has a wonderful job. He travels all around the world as a geologist and as a gemologist to be on the field, go into the mines, collect samples, documented samples to build up reference collections. And Nadia knows about this as well. Every major laboratory has reference collections that are collected by special people like Wim. So what Wim is going to tell us today in his experience as a field gemologist and what is the importance of it is really critical if you want to know what's behind the gemological report with origin information. So ladies and gentlemen, welcome. A big round of applause for Wim Vertriest from GIA. Thank you, my man.
All right, perfect. Oh, this is still on Rui size. So, good afternoon, everyone. I want to start with thanking ICA for inviting me here, because they sent me an email asking me if I could come give a talk on field gemology. And that was basically all they said. So I was a little bit confused, because there's so many things I can talk about. But while thinking about what I should talk about, the thought occurred to me that maybe we should just explore what field gemology really is. Because it's a term that gets thrown around a lot in the last decade, but nobody really can put their finger on what field gemology means, and even less why it's actually important. So that's something that I want to try and explore today. Why we do field gemology, who does field gemology, who should do field gemology, what is field gemology, and how it is important for every single one of us. So we have to go back to the basics, and that's something that was discussed earlier this morning. There's going to be a lot of references to the talks from Dr. Post and the lab panel that we had today. But going back to the essence of a gem lab, that is that a gem lab is there to answer questions for the trade. And those questions have evolved over time, and I think both Chris and Aaron and Tanong have touched upon this, that initially the question for the lab was, what is this stone? So basic identification. Now later on, a second question came on. Is it real? Especially synthetics, lab grown in the colored stone space. That was a big thing 40, 30 years ago. The diamond is going through that whole scene right now, but color stones have had that scene. And then in the last years, another question came up. And that question is, where is it from? Origin determination. People want to know if their ruby is from Burma, whether their ruby is from Mozambique. So that's an important question as well, that GIA tries to answer, and actually every gem lab out there tries to answer. Now at GIA, we take a scientific approach for this. And again, this is something that has been touched on in multiple of the previous talks. But a scientific approach for me consists of three very important pillars. The first one is obvious: qualified, experienced staff. You need people with a degree in relevant sciences. That could be earth science, that could be analytical chemistry. If you go into the pearl science, a biology, a life science degree is very helpful. But you also need people that are able to apply that to the gemological world. When I finished my master's degree at university, so 5 years of geology study, I came out and I didn't know that ruby was red and sapphire was blue. So while I did have a lot of skills that I could apply to gemstones, there was still a bit of a learning curve to make there. So again, that experienced staff is very important, and I think Chris and Aaron and Tanong touched upon that as well, that the experience of a gemologist cannot be underestimated. Second, advanced instrumentology, and that includes also advanced data processing. I'm going to use it again, the A word, artificial intelligence, but also just advanced instruments. You need people that are able to run this, people that are able to work with this. Because right now, everyone with $20,000 can go buy a UV spectroscope and get a wiggly line out of it. That doesn't mean that you know what that means. So using your advanced instruments is the most important. But even if you have an army of PhDs with 50 years of gemological experience each, and you have the most well-equipped laboratory in the world, and you let them do science, you let them research material, everything they do is going to be useless if it's not done on reliable samples. So those reliable samples are the key, because you can have Nobel Prize winners with billions of dollars of equipment looking at stuff. If they don't know what they're looking at, it's all rubbish to begin with. So those reliable samples, that's something that makes GIA's Field Gemology program very special. Now, what makes a collection reliable? And I could tell you, but I'm just going to use this quote from Sir David Attenborough, who's got way more respect than I do, even within this room. So he said in a video where he discussed collections that a research library associated with collections is almost of greater importance than the objects, in our case the gemstones themselves. Unless you know where it came from exactly and when it came from exactly, you're missing a lot of very, very important information. And that information not only comes from the gemstones themselves, but from the circumstances of documentation that should accompany every scientifically collected specimen. What he's basically saying here is, if you have a drawer full of stones, all you have is a drawer full of stones. You don't have a research collection that way. So that's why it's important, that's why GIA focuses on that field gemology department that is founded to build a collection of well-documented samples. Now, well-documented can mean different things, preserving that history. Dr. Post stressed upon that. That can be preserving that legacy, preserving those stories like the Smithsonian does. Now, we have a collection that is not as impressive as the Smithsonian for now, but we are working on it. But we have a different angle at it. So we focus more on what the origin of this material is, what the treatment status of this material is, whether we know it's treated or whether we don't know if it's treated. But most important of all is we try to use this collection for research projects. Because even if you have a ton of reliable samples and you have an army of PhDs and Nobel Prize winners and a fully equipped lab, if you don't bring all three of them together, you're not doing anything with it. So using that collection is a very important part of GIA's Field Gemology project as well. So a couple of projects we do are locality descriptions. For example, what do sapphires from Burma actually look like? And we do that by studying our sapphires we collected in Burma. But also treatment experiments. Low temperature treatment has been a big issue in the trade. We've tried to tackle that by selecting stones from our collection that we know are guaranteed untreated, because I took them out of the ground myself, so they've never been inside a furnace, documenting them, and then treating them and documenting again to see what the changes are during those experiments. So those are some of the examples that we use our research collections for. Now that's a beautiful theory. Now how do you put that into practice? Because you don't just go to the supermarket and buy a reliable collection with all the data attached. The easiest way to get your reliable samples is to go where the stones are. That's very straightforward. If you want to get reliable Ethiopian sapphires that you know are from Ethiopia and are untreated, this is the place to be. This is the river valley north of Aksum where those sapphires are mined. You can see all the little artisanal mining sites in the center of that valley. If you get a sapphire there out of the ground, you're pretty sure it's Ethiopian and you're pretty sure it's untreated. Now, GIA has done almost 100 expeditions to multiple locations throughout the world. I think here you see a map of where we've been. I think the color code speaks for himself. The black includes the mantoid, opal, and Paraiba tourmalines as well. Blue, green, and red, I hope I don't have to explain what that stands for. But you can see that there's a very tight concentration in East Africa, where there's a lot of ruby and sapphire deposits, Central Asia and Southeast Asia, which are the three main regions for ruby and sapphire deposits around the world. Now, going where the stones are also means something else. You can go straight to the mine, but that's obviously pretty complex. Going where the stones are also means this, because 1 week a year, the highest concentration of the most diverse stone takes place in Tucson, Arizona, in the middle of the desert. These are stones that are mined thousands, 10,000s of kilometers away, but they all gather there. So that's a perfect opportunity to see so many stones in such a short window of time, to meet so many people in such a short window of time, to learn so much updates about every place in the world in such an efficient way that it is critical to be at those places as well. I think intuitively we all understand that there's a difference in reliability of information that we can get there. If I go to the mine, I grab my hammer and I hit a rock and a 25-karat ruby comes out, fingers crossed that that ever happens, that is obviously way more reliable than going to Tucson and buy a stone for someone who says that his neighbor's butcher has been there once and he found this thing that he got from another guy. So that's what building a reliable collection, when we do that, we include a lot of information. So we include the stone information, the locality information, but in different ways. Obviously, GPS coordinates are important, but nobody talks in GPS coordinates. So writing down those names of those locations is important. But then especially with the angle that GIA is building this collection, the buying conditions and the relationship to the mining process is very important for us. So we've developed a classification system that gives us an indication of how reliable the information to that stone that is attached to that stone really is. So our first type that we have is an A-type. An A-type means that it's mined by the gemologist. Here we have my colleague, Dr. Palke, who's mining pink sapphires and rubies straight out of the rock in Greenland. I think we all agree that this is 100% Greenlandic material and that it's untreated. This is as Greenlandic as it gets. So an A-type sample is ideal, but I think those of you who have been to a gem mine realize that finding gem quality material during the short window that you are there, I think we've seen those graphs where we have to move 38,000 tons to get 120 grams of fine quality emerald. Those numbers roughly apply to every gem mine in the world, even if you scale it down. So a B-type would be that a gemologist has witnessed the mining. We're able to visit a lot of gemstone mines, but a lot of people don't allow you to pick up rocks there, because you could pick up a rock and walk out with $1 million in your pocket. So you sometimes have to hold your hands behind your back and just see what goes on there. Now still, we've seen this stone come out of the ground, we just haven't done it ourselves. So this is still a very reliable sample. A C-type sample would be we would collect it at the mine, but we haven't seen it being mined. This is an example from the MRM ruby mine in Mozambique, where we are able to select some rubies for GIA treatment experiments. We haven't seen these stones come out of the ground, but we are still at the mine site. So we still are relatively sure that they are actually from this place. We just don't know, are they from the mine this day? Are they mined 2 weeks ago? Did they come from this part of the pit? Did they come from that part of the pit? So there's already a little bit of information lost, a little bit of uncertainty there. Now D-type would be collected from a miner, but not at the mine. Here's a ruby miner on his way home. This is the Mogok Valley in the background. You can roughly make out the lake in the center of the village there. So we met this guy on his way home after his afternoon shift, and he said, "This is what I found today. Do you want to buy it?" So we were able to buy some things directly from the miner, but we have no idea where that mine exactly is. So you already understand there's more distance here between the buying and the actual mining. There's less reliability here. And an E-type sample would be collected from a secondary source close to the mines. That's basically in the local markets. So here I am dealing with this young spinel trader in Vietnam who drove a very tough bargain, but we did manage to get to an agreement to buy some spinels there. Now again, we're in a market here. We could be anywhere. This material could be sourced from anywhere. I've been through parcels in local markets that are half synthetics and half fakes. There is not even the real deal in there. So again, we understand an E-type sample. It's a good place to collect a lot of material because you see the amount of spinel that's on the table there is pretty nice, but it's less reliable than what it is, than what it could be. But still, it's a very convenient place to buy a lot of material. And then we have F-type samples that's collected from a secondary source in the international market. It's a running joke that a lot more people are getting right now, that if you ask for a Sri Lankan sapphire, you have to specify whether it's Sri Lankan or African Sri Lankan, because the highest concentration of Madagascar sapphires is not in Madagascar, it's in Beruwala, Sri Lanka. So here we are looking at Madagascar sapphires in Sri Lanka. Obviously, we have no idea where these stones came from. We just have to take the guy's word. So that's why that classification system is important, because these go into our collection as Madagascar sapphires. But if you don't note how reliable that information is, That is going to be very important for the research that you do next week, next month, next year, next decade, next century on these stones. So knowing that if we look at an F-type stone and it doesn't make any sense, we know why. Because it's an F-type stone and it's not very reliable. So that's why for a research collection, it is very important to have that reliability degree built into it. Now, how do you actually work with a reference collection? What do we do at GIA? So when we get this stone, we put those into cassettes, we store those physically, and you see here, all the information on this stone is collected on these cassettes. We also have that checklist of data that is collected to it. And all this information is transferred into an online database. Now, this database is accessible for GIA staff around the world, because we have colored stone facilities in New York, Carlsbad, Hong Kong, Tokyo, and Bangkok. So someone from Tokyo can look at a stone that is physically in Bangkok through the online properties through that database. Now, when we collect advanced data, like for example with our ICA, that long thing that Rui mentioned, we can put that in there as well, and people can use that data. When we collect more inclusion photos, like that spray of silk from a Burmese ruby on the top right, we can add that to it. So people can look inside the stone from a distance. Spectroscopy that's collected all gets added to that database, and that really builds up that database, makes it accessible for every single gemologist at GIA to look at these colored stones. Now, I want to have a little short note about the research that GIA does, because at this point we have, I think I wrote it down, and I don't want to make mistakes here, because I don't want to offend anyone. We have 7 postdoctoral researchers that are working at GIA on colored stone research projects. That goes from statistical analysis to turquoise to sapphire studies. We have 8 full-time research scientists spread around the globe working on colored stone research projects. They obviously have the support of all of our identification teams around the world, which is probably another 60 people or so, plus the field gemology team that helps them out for a lot of these projects. So that just stresses how much effort GIA is putting into research projects and how much that underlines and underpins all the services that we do. One of those services that we do that is based on a lot of the work that GIA's field gemology is doing are our origin determination services, which we do on ruby, sapphire, emerald, red spinel, alexandrite, and cuprian tourmaline. So all of that work is based on samples collected by GIA's field gemology team, by studies done by our research teams throughout the world to support those services to the trade. Now, field gemology, is that it? Is it going out there collecting stones and using them for research? No, field gemology is a lot more than building a reference collection. Obviously, for a laboratory environment, everything we just discussed is going to have priority. But for the rest of the trade, field gemology can be extremely valuable as well. So while we go out to the field, we are also documenting the gem trade. We support GIA education services by that, and we create an archive of information talking about mining, trading, manufacturing. Because if you go back 20 years and you look at works that are literature, videos, documentaries that are describing the way of the jewelry scene, we understand perfectly how the big brands work. We know how jewelry gets made. We might even figure out how a stone gets cut. But there is nothing about how does a stone get from a mine in Africa to a cutter in Thailand, to a treater in another place in Sri Lanka, finally into Hong Kong, making its way to Tucson, ending up at one of the brands. That is still very obscure. Nobody really knows what's going on there. And there's so many different trade lines. So trying to understand what's going on there is also a very important part of field gemology. Now, by supporting GIA education, we're trying to shine a little bit of a light on that. We do that by, during the pandemic, when we were all working on our personal growth, GIA offered a lot of free seminars online, which you can still check out on YouTube, where a lot of field gemology information made its way into, where we discuss emerald sources, sapphire sources, current treatment procedures of rubies and things like that, where we're able to go way more in depth and discuss those things. We've also developed a lot of, I think we've already mentioned the Gems and Gemology issue that GIA published on origin determination, which was a lot of work, but we've used a lot of that work and leveraged it into education programs as well. So we are now able to teach origin determination seminars, origin determination classes, where we give you more insight on the background, the back world of a laboratory, and how we actually look at gemstones when we try to identify the origin. And you get to know some of the characteristics that we use, some of the things we want to use, some of the things we cannot use. So we just try to lift as much of that obscurity on origin determination as we can through educating more and more people in the trade there. Now, I think we've talked a lot about things that field gemology matters, why it matters for education, why it matters for laboratories, but why should you guys care as traders? Because whatever the lab does, that's whatever the lab does. But I think field gemology is way more than that. And I'm going to break it down in 4 points. So why should you care about field gemology? Obviously, to try and understand the gems themselves better. That could be identification, that could be inclusions and chemistry, which is very important for origin determination, but that also includes more of the treatments. So field gemology is about trying to understand the gemstones. But field gemology is also trying to understand the trading, mine to market. How does a stone come out of the ground and end up in a ring somewhere or in jewelry somewhere? How are these stones evaluated throughout that entire process? How does a stone go from a rough crystal somewhere in Colombia to a cut stone somewhere in Israel? And I think that's very important when we're talking about things like traceability. So I think by doing field gemology, that can help you with that traceability questions. Now, field gemology is also trying to understand the mining and the mining environment. What are the techniques used? What's the geology and the geography at those places? What are the limitations of it? What's the deposit type and how does that relate to the gems? What's the environment like and what's the environmental impact like? And I think that's important for sustainability, for environmental sustainability. If you look into those questions, you can do field gemology for these reasons. Now, you can also do field gemology, you have to do field gemology to try and understand the source a little bit better. The history and development. If you want to understand the story of Mozambican ruby, you have to know that Mozambican ruby has only been around for 15 years. If you want to understand the history of Paraíba tourmaline, you have to know that these things haven't been around for thousands of years. That's important to know all of that. If you want to look at current trade trends, for example, I talked with Menahem earlier about gray spinel. It's important to know that these sources have produced these for hundreds of years, but nobody cared about them. By doing field gemology, you understand how all these things are connected. And then obviously the people as well, the culture as well. How does the culture of this country interlinks with the gemstones? You cannot talk about sapphires without talking about Sri Lanka, because Sri Lankan culture is so deeply intertwined with sapphires that it would be dishonest to neglect all of that. So the culture that is surrounding these gemstones is also important, exploring that. If you want to talk about heat treatment of rubies, you cannot ignore Thailand, because Thailand plays a vital role in there, and understanding that requires field gemology as well. Maneuvering the politics and the civil issues, which can have a huge impact on supply as well, that's understanding, that's field gemology as well, and that's all very important if you want to go into the sustainability aspect, the ethics aspect, looking at human conflict. So that's where field gemology is very important too. But I think field gemology, most important of all, is trying to understand the connection between all four of them. It is trying to understand the connection between the gemstones, the mining and the environment, the trading of the gemstones, and what happens at the source together. So I hope I convinced all of you that field gemology not only matters for the laboratory, but it matters for every single one of you. Because by doing a little bit more field gemology, every single one of us can do a better job at what they're doing right now. So with that, I want to thank you for inviting me. I want to thank everyone for attending. And if there are some questions, we could do them now or we could take them later. Thank you very much.
Great presentation. As I was delighted listening to you, honestly. It's such a delight to listen to a great communicator and great pictures and great information. Actually, your presentation brought me back to Jeffrey Post's presentation when he said that stones keep memories. And the memories that Dr. Post was sharing are memories of the latest owners and the kings and the queens. But the memories you conveyed are the geological memories, the mining memories, the families and the community memories. So that's a great way of seeing how important is what you just said. So thank you very much. We still have some time for questions. Do you want to address a question to, yes, El, you need a microphone. Could you stand up and say your
Hi,
name?
Elle Hill again. So a question: the stones that were tagged and had all the sticker on the box. How has technology been implemented to track the stones and connect them to the information about that stone so that they can't be separated or tampered with after you apply all that information to the outside of the plastic box?
Well, yeah, so we're not using the super high-tech material there. It's pretty old school. We stick a barcode on them, and we keep them in the bag with the barcode. Now, obviously, there are a lot of cross-checks. That digital database that we have has the exact weight, has the exact photos, has the exact description of that stone. If I find a ruby in a bag that's labeled emerald, I know something's wrong, and we can figure it out. But again, because we manage that collection very tightly right now, it is restricted within GIA. We are opening it up to certain academic institutions and have collaborated with them as well. But we keep a very tight control on those samples, where they go, and monitor it very closely. But we do that pretty old school.
Thank you.
Any more questions on the floor, gentlemen?
Thank you so much for your presentation. I'm coming from Madagascar. Actually, I'm the head of customs of Madagascar. So I see the presentation before. It's very interesting when you talk about sapphire coming from Sri Lanka. I agree there is a linked of story of sapphire and Sri Lanka, but also Madagascar knows. Last year, when the exportation of sapphire was blocked from Madagascar, the international market was suffering. To say that a lot of sapphire coming from Madagascar. But my question is, because those sapphire is coming from the mine, we are struggling about to contain, to put on the normal process. But can you, for example, to see the link of every stone can be tracked to know where it come from? And like you said, for example, it's in the market in Sri Lanka, but it's coming from Madagascar. So every single stone can be tracking with the origin of the stone, and how we can use for the legal market.
So I think this is a very complex issue that you bring up now. Tracing a stone back to a single mine is going to be scientifically very challenging. I think Sean from Gemfields proposed this idea where you need to go from the exact mine and the time to a certain to the market. That is going to be very difficult to scientifically support. You cannot look at the chemistry of a stone and say this was mined 5 years ago. It's already, you can use that information, use what is the scientific information analysis of your stone to say this matches sapphires that we know from Madagascar and not those from Sri Lanka. That's basically as much as we could do right now. And again, there is still a lot of overlap, but I think this leads into the debate of origin determination, which was touched upon this morning, and I think is a bit out of the scope now, but I'm happy to talk about that later on. But again, I think this stresses the importance of doing field gemology as well, because while we do know that Sri Lanka has a 2,000-year head start on Madagascar, Madagascar is incredibly important. But for someone who doesn't know about all those histories, for someone who hasn't done their field gemology, that is not clear. So it's important to know all of those things and then draw your conclusions from there. I'm not going to tell you what is right or wrong. I'm just going to tell you, look it up and figure it out by yourself. Because this is such a complex issue, there are so many sides on this, that by doing some field gemology, you will learn more about it, you will try to understand more about it, and you will be able to draw your conclusions and draw some lessons from that and move on from there. That might be very different conclusions than what I draw, because we talked about what is the absolute truth earlier as well. I think this comes back to that as well. We work with the information that we have and we draw conclusions on that. But by doing a little bit more field gemology, you are able to find a lot more extra information that is maybe going to help you to find a different answer there. But we should definitely talk about this later on.
Menachem? Go ahead.
I think there's a switch on.
Yep.
Or I can repeat it.
The
No.
microphone, please.
There we go.
Okay. First of all, I can always remember Richard Liddicoat saying to me and to other gemologists that we thought were very clever, determining the origin of a stone is no more than a well-educated guess. Now, 20-something years later, he was quite right. It's a very, very well-educated guess with a lot of machines. But I will tell you, for example, field gemology, as you said. 3 months ago, we were in Tanzania with my son Kobe, and they showed us a rough that came out of a new source in Tanzania. We were in Arusha. They showed us the rough sapphires, the new source. And my son Kobe told me, didn't they show us that before and they said it came from Umba River? That means this supposed to be sourcing can mix the thing. So really, this thing is, we are guessing. Yes, we are very well educated now with all the new machines, but I think we should not pretend that we always know precisely where this stone come from, because I don't think it is possible.
I agree with that. I think that's why these are called, these are reports, not certificates. But that's another debate that we open up there. But you're right. This is a well-educated opinion from people in the lab. That's why experience matters. But you are also right. We are way better educated than before. And like you said, when you are looking at stones in the secondary market in a local place, so the condition, if I were sitting next to you looking at those stones and somebody told me these came from a new place, I would have tagged those as E-type samples. When I get back to the lab and they exactly match Umba sapphires, these would be reclassified and every reliability on those stones would be ignored. These would be back of the line, least reliable we can, and we ignore the origin of those so far.
That's why we like in our certificate, it's not well, in the opinion of it is the best
10 seconds.
of the gemologists that this is a Vertriest, because you can never really know, but it's the best opinion.
Correct. And I think that terminology on how that is put on the reports, I think almost every lab has the same meaning, just different words in there. But you're right about that.
Thank you very much. Before Menachem asks another question. Thank you, Wim. Great, excellent as always. Thank you very much for your wonderful presentation.